Hello everyone, today I will talk about asymptotes of a curve. First, we will understand what it represents actually, and then we will go for the calculation first. That means how to find asymptotes for a given curve. So let me write down first the definition. Asymptotes are straight line is said to be asymptote of a curve if it is a tangent to the curve at infinity point. Okay, so what it says, the definition says that asymptotes is a straight line which becomes tangent to that curve at infinity points. Okay, now we will understand this definition by taking a particular graph. You all know that hyperbola y equals to 1 by x text. This is an hyperbola, and if we plot the graph, it looks like this. This is the one branch, and the another one branch goes in that way. Okay, see these portions. Now this is the x-axis and the curve. The distance between them is becoming closer and closer and closer. At the point of infinity, we can say that x-axis will meet to the curve. We shall not say meet, we should say that x-axis will touch to the curve. Since x-axis touching to the curve at infinity, that means x-axis becoming a tangent to the curve at infinity. Likewise, the y-axis is this portion is also touching to the curve at infinity. So we can say that x-axis and y-axis, these are the asymptotes for the curve. This is the y-axis and this is the x-axis. Okay, so we have a little bit understanding what is the meaning for a tangent to a curve. And observe that here two asymptotes we are getting from a single curve. So the question that comes, that if a curve is given, then how many asymptotes we can get? Okay, and before that, also another questions. If I give you any curve, then shall I get asymptote always? Is it possible? Of course not, because see, this is a tangent to the curve at infinity points. If I give you a curve which has a finite regions, that means that curve has no point at infinity or not extended to the infinity, then of course that curve will not have a tangent. For example, circle, so it is a note that circle, ellipse and parabola, they do not have asymptotes. Okay, the answer is pretty obvious. For the circles, if we take a circle, if we draw a circle here, then what is coming? See, for the circle it has only finite regions. This circle is not extended to the finite. So a straight line is a tangent to this curve at infinity, that doesn't make any sense. So there is no asymptotes for these curves. Likewise, ellipse can be treated in that way, that ellipse does not have any curve. And for the parabola portions, though it is extended to the infinite portions, still it can't have asymptotes. You will understand this after few minutes, because when we will give more details about the asymptotes, then eventually we'll understand that why parabola is a curve which do not have any asymptotes. Okay. So the next, for a given curve, now the question comes, now for a given curve, how many asymptotes we can have? Suppose we have the curve, like given curve is f of xy equals to 0, and for understanding, take a particular fx. For example, the particular fx would be xy squared minus x cubed minus y squared equals to 0. Suppose this is a particular f of xy. Now, how many asymptotes we can get here? The number of asymptotes, the answer would be number of asymptotes equals to highest degree of fx. This is highest degree of fx. Now, highest degree of f, the result is, for in this particular case, what is the highest degree? See, the highest degree is by adding x and y. That portion will be the highest one. Now see, if we add x and y, we give x cubed. Though we have x with 3 degree, so the highest degree is 3. In particular, for this, we will have number of asymptotes 3. Okay. All right. Now the next questions. Among these 3 asymptotes, some of the asymptotes will be parallel to coordinate axis, that means parallel to x-axis or y-axis, and some of the asymptotes will be not parallel to coordinate axis. Of course, this will happen because asymptote is a straight line, so a straight line, it has to be either parallel to coordinate axis or not parallel to coordinate axis. So okay, let me write down the asymptotes, that it will be parallel to coordinate axis and another one is not parallel to one axis. I will write here first. A portion, parallel asymptote can be asymptotes parallel to coordinate axis. This is the one portion. Now the asymptotes parallel to coordinate axis, either it would be vertical asymptotes, or it would be horizontal asymptotes. Okay. And the next one, asymptotes which is not parallel to coordinate axis. These portions. There are 2 possibilities. So first one, if the asymptote is vertical, that means y-axis itself vertical. So the vertical asymptotes the equation for vertical asymptotes, it looks like it's the same, like similar to the y-axis. Equation of y-axis is x equals to 0. So the vertical asymptotes will look like x equals to k, and the horizontal asymptotes, that is the parallel with x-axis, for the equation it will be like, oh, let's skip k1 and this gives k2. Okay. And the another portion, those asymptotes which are not parallel to coordinate axis, that have a slope, that's why they are not parallel to coordinate axis. So that means it has a slope. So the straight line which has slopes, they looks like this form, y equal to mx plus c. We are getting two types of asymptotes. Let me tell you, these asymptotes which are either vertical or horizontal, they are very easy to get from the given curve. You can just watch the curve and you can say which one is vertical and which one is horizontal. So this portion is very easy. Let me write down that this, to getting these asymptotes, no calculation is required. And for this, a rigorous calculation is required. Now, as this can be easily solved, so MCQ question mostly target these portions. So we will have first discussion in this asymptotes, and after that we will go for this one. Okay. Okay, now how to find these vertical asymptotes first? The formula is very simple. What you have to do, first make the coefficient of, since it is vertical, so coefficient of y to the power n. Y to the power n is the highest power of y. Highest power of y. Make it equals to 0. And for horizontal asymptotes, coefficient of x to the power n, highest power of x equals to 0. Now see, coefficient of y to the power n, highest power of y, in the curve, of course, that I didn't write, because to give you a brief formula. Okay, I will find out this one. To calculate this one, let's take an example. The example we have already taken here, this person's. So let's bring it here. So the problem is, number 1, f of xy equals to xy square minus x cube minus y square equals to 2. Let's take another one. Okay, I will take it from, and another one is x cube plus y cube equals to 3a xy. Okay, we're gonna solve this. First, let me clean this portion. Okay, now for the first one, we want to find out vertical asymptotes and horizontal asymptotes. For vertical asymptotes, how will we find? The formula is coefficient of y to the power n equals to 0. So coefficient of y to the power n, highest power of y. What is the highest power of y here? The highest power of y is equals to y square is the highest power of y. Y square is equals to 0. This gives coefficient of y square equals to x minus 1. X minus 1 equals to 0. This gives x equals to 1. So this is a x equals to 1 is the vertical asymptotes. Okay, we don't need to write these portions because we have already written here that it is a vertical asymptotes. Next, for the horizontal asymptotes. Okay. Coefficient of x, highest power of x. What is the highest power of x here? See, the highest power of x is x cubed. So x cubed, this is equals to 0. Now x cube has coefficient constant. If it has a coefficient constant, then this equation becomes a mismatch because it will give you minus 1 equals to 0. That cannot happen. Therefore, we will say that there is no horizontal asymptotes. Coefficient of x cube we will write here like this way. Since coefficient of x cube is constant, so there is no horizontal asymptotes. Okay. With this same logic, this equation will be so easy to solve. Look, highest power of y is y cubed, highest power of x is x cubed. Now what are their coefficients? Coefficient of x cube is constant, coefficient of y cube is constant, because here is x and y have only 2 power, so this is the highest power. Since the coefficient of x, highest power of x and highest power of y is coefficient constant, so we can say that there is no vertical or horizontal asymptotes for the curve 2. We shall write here for 2 portions, since coefficient of x cube and coefficient of y cube are constant, so there is no vertical or horizontal asymptotes. Okay, so we have the results. So you can see that this is pretty easy to solve these portions, and as I told you that this is so easy, that's why the MCQ questions would target these portions. So let's take a MCQ type questions, how to find them and what are the questions that may appear as a MCQ type. Just a minute. Okay. The question number 1. Question number 1. Which of the following curve have asymptote parallel to coordinate axis? Have asymptote parallel to coordinate axis. Okay. The number 1 is y is equals to log x. Number 2, y is equals to tan x. Number 3, y squared is equals to 4ax. And number 4, x squared plus y squared is equals to 9. Well, we have these MCQ questions. Question is, among these 4 curves, which one have parallel asymptotes? I mean parallel to coordinate axis, that type of asymptotes. Okay, so we start solving with this one. First, look at this. These equations do not have x and y separately. That means x is here with a function log. So you cannot say that okay, to check we have to find out the coefficient of y and then we have to find out the coefficient of x. See, coefficient of y is very easy here because we can rearrange this in this way. Okay, now see, the coefficient of y is 1 by log x, so it should be 0, and this gives log x equals to infinity, x equals to infinity. Since x is not giving any finite value, therefore it will not be, there will not be a vertical asymptote. For the horizontal asymptotes, what will we do? Coefficient of x we will consider. How to consider the coefficient of x? This can rearrange like this way, x equals to e to the power y. Now you can have coefficient of x 1 by e to the power y into x equals to 1. Therefore 1 by e to the power y equals to, using formula, coefficient equals to 0 gives e to the power y equals to infinity, gives y equals to infinity. See, x and y in both sides there is no finite value. Therefore this equation can't have a asymptote which is parallel to coordinate axis. So this result is not true. Likewise, we can check in this way for 2, 3 and 4. Okay, for number 2, y equals to tan x. It has the coefficient 1 by tan x is equals to 0. So tan x is equals to infinity. That gives infinity equals to tan pi by 2. That gives x equals to 2n plus 1 pi by 2. You can see that it is giving asymptotes. We don't need to calculate these things. I will, because eventually we will understand if this uh, 2 was given in the 4, then we have to check this percent. Likewise, you can figure out the coefficient of x also. How will you get the coefficient of x? The coefficient of x, you will be like this way: tan inverse y into x. The coefficient of x will come, and another one will be 1 by tan inverse y is equals to 0. Because you know these portions, what I am doing, I am making inverse of tan in this, and then we are just dividing by tan inverse y and taking it into right side. Therefore 1 by tan inverse y becoming the coefficient of x, and now we are making here 1 by tan inverse y, that means coefficient of x is equals to 0. And using calculation, okay, let me calculate these portions too. Tan inverse y equals to infinity. Y equals to tan infinity. Now see, tan infinity, there is no such type of things. So y can't have no finite value. Not decidable. Okay, so these portions cancel out. Now see these portions, the coefficient of y, we will check. The coefficient of y will be 1 by 4ax. Coefficient of y square equals to 0. This gives 1 by x is equals to 4ax is equals to 0. This gives x equals to infinity. Not true. Coefficient of x is equals to 0. This gives 1 by y square equals to 0. This gives y equals to 0. Y equals to infinity. So these portions suggest that this can't have asymptotes parallel to coordinate axis. In this similar way, and this look at the 4%. This is a circle, finite region. So of course it can't have asymptotes. 2 is the correct option. Okay. Let's take another one. The next question is, which of the following curve have vertical asymptotes? Okay, vertical asymptotes. And number 1 is y equals to tan inverse x. Number 2, y is equals to e to the power x. Number 3, y is equals to e to the power minus x. Number 4, xy square minus y square minus x cube equals to 0. Okay. We have to figure out which one among these 4 have a vertical asymptotes. Even if we find a horizontal asymptotes, that will not be considered here. We have to find a vertical asymptotes. For these portions, like I did it before, the as we seen in the previous example, that coefficient of y equals to 0 gives 1 by tan inverse x equals to 0. This was not giving any finite value, so this person is not gonna give you the finite value for x. I'm not doing the other portions. You can just go a little back. There is, I have calculated. Okay, now the coefficient of x is equals to 0. How to solve? Coefficient of x is 1 by tan y. 1 by tan y. Make it 0. After that, we can have tan y is equals to infinity. That means it is equals to tan pi by 2, which gives y equals to 2n plus 1 pi by 2. Okay. See, we are having asymptotes here. But look, these asymptotes, y equals to something. This is not vertical. This is a horizontal. This asymptotes will not be considered for the curve. So these options are being cancelled out. For the next one, y equals to e to the power x. Coefficient of y equals to 0. This gives 1 by e to the power x is equals to 0. This gives x equals to infinity. So it's not true. For the other parts, coefficient of log y. Similarly, the coefficient of x, this gives, you can operate log both sides, and after that you can just divide by log y. So it will be 1 by log y. 1 by log y equals to 0. This will be log y equals to infinity, y equals to infinity. These options is also being cancelled out. Now, in the similar manner, this will also be cancelled out. Same like this. Now we go for the fourth option. This has to be true because one of the options must be true. We will check how it is becoming true for the part. That means we will find out a vertical asymptotes here. How to do that? The coefficient of x cube, highest part, coefficient of x cube. Okay, these equations I have solved. Let me do again. Coefficient of, but since we need the vertical asymptotes, we just calculate coefficient of y. Coefficient of y. The highest power of y is y squared equals to 0. This comes x minus 1 is equals to 0. This gives x equals to 1, which is a vertical asymptotes. Okay, so this portion is the right. Alright. Okay, we are done with these asymptotes which are parallel to the coordinate axis. Now we will go for asymptotes which are not parallel to coordinate axis. That is a little bit sticky, that portions. You have to do a rigorous calculation, but that calculation is very straightforward. You can do so easily. Just you have to remember and be careful while doing the calculation. Other part is so easy. Okay, now the asymptotes not parallel to coordinate axis. working group.